Hi guys, in this video we're going to talk about reduced row echelon form on page 548. So in the last video we talked about row echelon form. Now we are talking about reduced row echelon form, which is the best way we can do. So, if we continue to apply elementary row operations to a row echelon form of a matrix, we can obtain a matrix in which every column that has a leading one has a zeros elsewhere. So this we call as a reduced row echelon form. So which our goal is so that we are going to make a 1 0 0 0 1 0 0 0 1. We are going to have something here that would be our solution directly, right? So this whole thing we called as a reduced row echelon form. Reduced row echelon form. So it's a little bit different as just row echelon form, right? All right, so we're going to work on page 549 now. Example 5. So we are going to do example 5 and 6 in this video. All right, example 5. Solve the system x plus y plus z equals 3, 2x plus y plus 4z equals 8, x plus 2y minus z equals 1. Okay, so actually in this part we practice a reduced echelon form, a row echelon form. So when you look at the figure 7.15 with 7.15, there has a tool to find the reduced row echelon form about the question. So I used my calculator to here, but I found that that's only offered for the premium version of it. I download the other calculators and that's as well. So I believe that your own calculator has a tab, so that I just want to show you where it is and then that's it. So as I mentioned before, that your all calculators are different kinds and different brands. They have all different features on it, so please make sure to use your manual book to find out that has the function on it. So in this calculator I tap the second and the matrix so that you can find out all of that. That's the math for the matrix. So when I go down, they have a REF, that means a reduced row echelon form. I click that just popped the message that there should be a this one should be purchased. So I couldn't really do by using my calculator, but you could calculate it with your hand. Okay. And if you have your calculator has this function, you may use that as well. So for now, let's practice how we make that. Okay. So for now, we're going to make a row echelon form, which is 1 1 1 3 2 1 4 8 1 2 negative 1 1. I just want to double check it before we starting. I don't want to make any mistake. 1 1 1 3 2 1 4 8 1 2 negative 1 1. Yes. So my goal from here to make the row echelon form, you guys remember what it is, right? So I would do negative 2 times R1 plus R2 so that I can cancel my 2 out. So here, if I times negative 2 on my first row, that would be negative 2, negative 2, negative 2, negative 6. After that, what? You're going to add all up with the second row so that you can cancel that one out. So 2 plus negative to become 0. 1 plus negative to become negative 1. 4 plus negative to become positive 2. I was about to put negative 2. And 8 a minus 6 become 2. Now I'm going to keep everything here. Now how I can make to cancel my first number here. I don't need that, right? So you do negative R1. I'm going to put it on the arrow. Negative R1 plus R3, then I can cancel out. So if you times negative 1 to your first row, that will be negative 1, negative 1, negative 1, and 3. Negative 3. So now I had 1, 1, 1, 3, 0, negative 1, 2, 2. Now I subtract, I add this with this, my new row. 1 plus negative 1 becomes 0. 2 plus negative 1 become 1. Negative 1 plus negative 1 become negative 2. And 1 plus negative 3 become negative 2. Okay? And then, now I have my answer would be, if you add R2 plus R1, so that I'm going to cancel my 1 out, which become 1, 0, 3, 5. And then you have 1, negative 1, 2, 2, 0, 1, negative 2, and negative 2. So I may switch my R to R3, then you would have 1, 0, 3, 5, 0, 1, negative 2, negative 2. 0, negative 1, 2, 2. I wanted to cancel out my negative 1, so I'm going to add my second row to third row. And I would have 1, 0, 3, 5, 0, 1, negative 2, negative 2. And then, once you add them up, 0, 0, 0, 0. Okay. It's just gone. My last one is just all gone. So, you can check all the numbers on the figure 7.15. That shows the reduced row echelon form. I just got this, right? So I can rewrite that part as a system format. It would be x plus 3z equals 5. Y minus 2z equals negative 2, 0 equals 0. So solving the two first equations for x and y in terms of z, what's gonna happen? Your x would be negative 3z plus 5. And your y would be 2z minus 2. So this system has infinitely many solutions, because for every value of z, we can use these two equations to find corresponding values of x and y. So, you can see that this case will have infinitely many solutions. So how do we interpret this answer? That's gonna be the one thing. So in this case, that we are going to use the ordered triples, which is a form of x. Instead of putting just x, you're going to use this expression, negative 3z plus 5. That's going to be my x. 2z minus 2 would be my y. And then just z, because, z is any number. It can be any number. Okay? That is going to be our answer, where z is any real number. All right? So now we're going to work on number 39. So once again, if your calculator, by the way, we are on the page 553, number 39. Okay, so if you have, your calculator has this function, you may use that. And then I also needed you to do it by yourself for practice, but you can double check with your graphing calculator. All right, you guys may start it, and then you can check the answer after. Okay, so we are on page 553, number 39. So my question is this. X plus z equals 2. 2x plus y plus z equals 5. So in this time, we would make into reduced to row echelon form. So I would do x and z. So we don't have any y. You are going to replace as a 0. 1, 0, 1, 2. 2, 1, 1, 5. So my first row, first column is already 1. So that's already satisfied. And then my first row, second column is 0. Now my goal is to make sure that I can cancel out my 2 here. How do I do it? You're going to multiply negative 2 to R1 plus R2. If you times negative 2 on your first row, it will be negative 2, 0, negative 2, negative 4. Now I'm going to add them up. 1, 0, 1, 2, nothing changed. Negative 2 plus 0 cancels. 1 plus 0, 1. 1 plus negative 2 become negative 1. 5 plus negative 4 become 1. So, that will be my echelon form. So I'm going to change that into the system format. That would be, give you this. X plus z equal 2. And then y minus z equal 1. So that I can rewrite my answer x as, in terms of z, negative z plus 2. And my answer y would be z plus 1. So as we had that situation, what situation is it? Infinitely many solutions. Because, if you set up any z, then you can determine your x and y in terms of z. So how can you represent in your answer this time? Your z would be negative, your x would be negative z plus 2. Y would be z plus 1. And then your z is just z. So your answer is infinitely many solutions. Okay, so let's go back to the previous question, 549. And we're going to talk about example 6. Okay, so let me copy my question down, which is x plus 2y minus 3z equals negative 1. 2x plus 3y minus 4z equals negative 1. 3x plus 5y minus 7z plus w equal negative 2. So we are going to make a, augmented matrix first, and then our goal is to make to the reduced row echelon form, right? As I mentioned, you can use your graphing calculator if you have that, but please practice by your hand, and then you can just make sure that your answer is correct by using graphing calculator if you have this function in your calculator. So for now, I'm going to write down the augmented matrix, which is 1, 2, negative 3. Make sure put the 0 for your letter W. And I forgot to put the W here. Negative 1, 2, 3, negative 4, 1, negative 1. 3, 5, negative 7, 1, negative 2. Okay? So now we are having this one to apply the, operations so that we can make the reduced row echelon form. First, I wanted to cancel out my 2. So what I'm going to do, I'm going to do negative 2 R1 plus R2. If you times negative 2, negative 4, positive 6, 0, positive 2. Now add up to your second one. So keep your first row samely. Second row, 2 plus negative 2, 0. 3, negative 4, negative 1. 6 plus negative 4, positive 2. 1 plus 0, 1. Negative 1 plus 2 become positive 1. Now 3, 5, negative 7, 1, negative 2. Now my second step, I want you to cancel my 3 out. So negative 3 to the first row plus third row. That would be negative 3 if you do everything negative 3. Negative 6, positive 9. And then 0, negative 6. You're gonna keep your first one, right? 1, 2, negative 3, 0, negative 1. Second, keep it right. And third, 3 plus negative 3, 0. Negative 1, 2, 1. No, that's 4. So I times negative 3 on that. Okay, so that would be, hold on. If I times negative 3, that would be, one more time, check it. I don't want to make any mistake. Okay. Yeah, I made a mistake here. That's positive 3, right? 1 times 3, 3, 6, 9. Yeah. Now good. Okay, so go down. You're going to add up to your third one. That's gonna be 2, 1, 1. Oh, that's exactly the same. Now, I want you to make that my 2 here cancel out. So I'm going to times 2 with my second row to add the first row. So if you times 2 into the second row, that would be 0, 0, negative 2, 4, 2, 2. I'm going to add up to my first one. 1, and then 0, 1, 2, 1. So 1, 0, 1, 2, 1. I got 0, negative 1, 2, 1, 1. 0, negative 1, 2, 1, 1. Now times negative 1 to the second row so that I can make into 1. And that would be 1, 0, 1, 2, 1, 0, 1, negative 2, negative 1, negative 1, 0, negative 1, 2, negative, positive 1, and 1. So I try to cancel out my negative 1, so I'm going to add second row to third row. What's going to happen? They're exactly all 0 coming out. So 1, 0, 1, 2, 1, 0, 1, negative 2, negative 1, negative 1, and 0, 0, 0, 0, 0. Okay, I'm done. That is my reduced row echelon form. Now, change that into the system form, which is x plus z plus 2w equals 1. And then y minus 2z minus w equal negative 1. That's what we have. So write down as in terms of x and y. And that would be x equal negative z minus 2w plus 1. And your y equals 2z plus w minus 1. So that your ordered four tuple form, which is x, instead of x, what you need to put? Z minus 2w plus 1. Instead of your y, 2z plus w minus 1. Now, what? Z and w. So, as you guys see that this system has infinitely many solutions, because for every pair of values for z and w, we can use these two equations to find corresponding values for x and y. Okay? Alright, so I want you guys to work on number 43 now. Alright, let's review together page 553, number 43. Okay, we have x plus y minus 3z equals 1. X minus z minus w equals 2. 2x plus y minus 4z minus w equals 3. Just let me make sure to copy the question correctly. Okay, now our goal is to find out the reduced row echelon form. So please write down the augmented matrix first. So since we have 4 letters, if you have something missing, please replace as a 0. So I got x, y, z, w as a 0, 1. X, y, z, w, and the number. X, y, z, w, and the number. So this is going to be our augmented matrix form. Double check it before you go, because if you find out you messed up in the middle of that, you have to restart all over again. So yeah, so every single time we need to check. Alright, now my goal is to make into the reduced row echelon form. Now first, I want you to cancel my 1 out. So I'm going to times -1 for my first row, add up to my second row. So if you times negative everything, you would have a -1, -1, +3, 0, -1. You need to add onto your first one, so just keep it same for your first row. Second row, -1 plus 1, 0. -1 plus 0, -1. -1 plus 3, 2. -1 plus 0, -1. 2 plus -1, +1. And write it down. Okay, let me double check it before you go. So we are adding now this and this, right? So -1 and 1, 0. 0, -1, -1. -1, 3, 2. -1, 0, -1. 2 plus -1 and 1. Okay. So we good. Now my second row, I want you to cancel my third, which is 2, right here. So I'm gonna do negative through 2 times first row, add the third row. Okay? So if you times -2 for your first row, you got -2, -2, +6, 0, -2. That's gonna be your first row. So as we did, keep your first row same, and then add up to the third row. So I had 1, 1, -3, 0, 1, 3 now. Okay? Just make sure that your times 2, which is -2, is everything correct. Okay. Now, keep my second one, 0, -1, 2, -1, 1. Keep it. And my third row, if you're adding them up. So now I'm going to work with this line with this line. So 2 plus -2, 0. 1 plus -2, -1. -4 plus 6, +2. -1 and 1. Oh, Okay, I found something that second and third line exactly the same. So we know that we are going to have infinitely many solutions, right? Again, now, but still this is not a row, reduced to row echelon form, so I need to keep going. So if you add second row into the first row, I can cancel my 1 out. So you would have 1, 0, -1, -1, 2. That's going to be your first row. 0, 1, 0, -1, -1, 2. Okay, looks good. Now, keep everything down. Now what do? You add second 2. If you times -1 to second row so that you can change into your second number -1 into positive, right? So I'm going to times -1 to second row, changing everything into the opposite sign. Keep first row, change everything into the opposite number. Now what? Add the second to third. Then you are going to have this. 1, 0, -1, -1, 2. 0, 1, -2, 1, -1, 0, 0, 0, 0, 0. Alright, so now we are having the row, reduced to row echelon form, which is 1, 0, -1, -1, 2, 0, 1, -2, 1, -1, and 0, 0, 0, 0, 0. Now, what is going to be my answer then? I have to change that into the system form, which is x minus g minus w equals 2. Y minus 2z plus w equals -1. Write down in terms of write down for x and y. It will be x equals z plus w plus 2. Y equal 2z minus w minus 1. Alright, it looks good. Now, you can make 4, which is the, all ordered form, which is ordered quadruple, which is z plus w plus 2. That's for x. 2z minus w minus 1 for y, and z and w. So your answer is infinitely many solutions. Alright, I hope this video helps you understand. We are going to see in the next video. Bye.